Good morning everyone, welcome back to your physics class. And as you know that we are learning our very first chapter, that is measurements and experimentation, and in that chapter we now have reached to our last topic, that is simple pendulum. We are going to see what is simple pendulum, and eventually we are going to see how can we measure the time of a simple pendulum, or how can we draw the mathematical expression of time to calculate the time period of a simple pendulum. Time, I think you all know, you have so far you have learned about time, mass, all the fundamental physical quantities you have learned about that. So here we are going to see simple pendulum. So first we talk about where did we hear the word pendulum first. If you remember, nowadays so we don't have, but if you remember, or in case you have it, like at home we have a wall clock where we have this pendulum thing which does tick tock. So yes, that pendulum we are talking about, but which type of pendulum we are taking? Simple pendulum. Although in our clocks which we use is compound pendulum. So but here we are going to take a system which is known as simple pendulum. So first we are going to see what is actually a setup of simple pendulum, which thing is known as simple pendulum. So now if I tell you what is simple pendulum, there is actually a heavy point mass. So here you are taking a heavy point mass. You can consider a ball, an iron ball, okay, of very small radius. So you can take an iron ball of a very small radius, and then we attach a string, and this is further attached to a rigid support. Okay, now this is the setup of simple pendulum, where we have a rigid support and then we have this string attached, and with that string we are having a heavy point mass. So let me write the thing and then we discuss what are the things we are taking. Heavy point mass we are taking, then this is our rigid support. Of course we want a rigid support. And next what we have, this string. This string is actually massless and inextensible. Okay, now let's see all the things one by one. First, what is a simple pendulum? It is simply a heavy point mass attached with a string and then attached with a rigid support. This system or this setup is your simple pendulum. Now let us come to this point where we are taking a heavy point mass. Can you all imagine a small iron ball or any ball, a dense one? So this is simply a heavy point mass. Why are we calling a point mass? It is very small. So here we are taking a heavy point mass. Heavy point mass, first thing, whatever this system we are taking, or this iron ball or body we are taking, this should be heavy. And point means the radius of this bob should be very small. So it is very small, so that we can call it point. So it is heavy point mass. Of course this is an ideal case, because you cannot take something which is heavy as a point of something, you know. So but this is an ideal case. So we are taking something which is heavy, and then the radius of that ball or that sphere, you can call it, is very small, and that's why we are calling it a heavy point mass. Then it is attached with a string. Now there is a quality of the string as well. We are taking a string which is massless and inextensible. So here we are talking about massless and inextensible string. So simply, what is massless and inextensible? So first, what is massless? Actually we are taking a string. Of course it will have some mass, because we cannot take something which is having no mass, but here we are taking a string which is massless. We are calling it massless. In comparison, the mass of the string is very small in comparison of the bob, and that's why we can easily neglect the mass of the string, and that's why we are calling it massless. Is it clear? We are taking the mass of the string very less or very small in comparison of bob, and that's why we can easily neglect the mass of the string, and that's why we are calling it massless. And then we are taking it inextensible. Inextensible, if I write it for you, inextensible. Something which is extensible, that means it can easily stretch or it can easily extend. Here we are taking inextensible, that means a string which cannot extend further. Like see, if you take a string and you attach a mass over here, when you leave the mass, of course the string will get stressed, or there will be a tension in the string, because there is a mass hanging in the string. So here we are taking a string where if you are leaving a mass in the string is having some stretch, but a uniform stretch first thing, and it is not stretching unevenly. So the tension throughout in the string is all everywhere common. Now if I tell you, if I am using the word tension and you are not aware of the thing, if you are taking a string and you are attaching a mass with the string, of course the weight of the mass or weight of the body will be acting downward, weight of the body, or let me write it as W. Okay, so this is the weight of the body. The weight will be acting because of the gravity downwards. So there will be a tension in the string, of course, in the upward direction. So that means there will be a stretch in the string. But we are taking such string which is inextensible, which is not stretching unevenly, or which is not stretching कि यहाँ पे ज़्यादा stretch हो गया and here it is very less. We are taking a string which is stretching commonly throughout. The stretch or throughout the tension is same, it is not changing point to point, so that here it is more and here it is less. So that's how we are taking a massless and inextensible. And you see, these are all ideal condition. Massless is ideal condition, of course, and inextensible. You are taking a string which is inextensible, or you can say the tension throughout is same, or it is not stretching that easily. And that's how we are taking a system which is massless and inextensible. So here we are with our system. I hope it is clear now. What is a simple pendulum? It is a bob, or, and I did not tell you, sorry. By the way, this mass which we are attaching, this iron solid sphere which we are attaching, is known as bob. We call it as bob, and then we are having massless and inextensible string attached with the rigid support, and this system is known as simple pendulum. Okay, so now simple pendulum, we are going, our idea is what here, that we are going to calculate the time period of the simple pendulum. Now how are we going to calculate the time period? You see, if we take this bob and we take it to some distance, or we just push it from, we drag it to this side and we push it from here, so of course it will start doing this to and fro motion. Can you see? Just imagine in your head that if you take the system and you just displace the bob a little bit. Okay, how are we going to calculate the time period in the simple pendulum? Our idea is to calculate the time period in this simple pendulum. How are we going to calculate the time period of the simple pendulum? So now what to do, that we are going to displace the bob a little. But now you imagine in your head that what happens if we take the bob, if we hold the bob and we displace it from its this position, what we are going to learn what this position is called. So if we displace the bob, we drag it here and we leave it. So what you see, this bob will start doing the to and fro motion. It will come to this side, go back, and it will go to that side, come back. So this motion is known as to and fro motion. And when this bob is doing to and fro motion, of course it will take some time. So we are going to see, and we are going to draw a conclusion that how can we measure time using this condition. Is it clear? So now you see, first there are some terms related to simple pendulum. We are going to see those terms first, and then we'll draw the conclusion for time period. So our very first term is oscillation. Let me tell you what is an oscillation is. Clear? Now if you take a simple pendulum attached with the string, and there is a bob, of course a dense mass, and if you are having this a dense object, and here it is your simple pendulum. Now oscillation, as I told you, if we displace the bob a little bit, so it will start doing a to and fro motion. That means if this point of the bob or this position of the bob, we call it as O position. So when we are taking it here, so we are bringing it here to this point, let us call it A, then it will, and when we are dragging it here, and when we leave the bob, what will happen? It will go to point O, and after that will it stop? No, it will go further to that side at point B. So now you see the position. Bob was there at point O. When we are displacing it, it is coming to A, going back to O, now going to B and coming back to O. That means it is actually doing a to and fro motion, and this to and fro motion is known as oscillation, like one oscillation. If you take the bob at this position, it will come here, it will go back, it will go to that side and come back, and this is known as one oscillation. Okay. Okay, so when the bob is coming to this point and going back to this point O, and then it is going to B and then coming back to O, is known as one oscillation. To this position, going back to that position, coming back, this is known as oscillation, and this is one oscillation, and likewise it will be doing this oscillations continuously. So that's how we have come to the idea of this oscillation. Okay. Now our next thing is, what is a time period of a simple pendulum? Next is time period of a simple pendulum. Okay, now you know that we are talking about time period. See, if you take this simple pendulum, as we know that what is one oscillation, the bob is here at point O. Okay, by the way, this setup where the bob is at point A is known as its mean position. Where it is resting, it is known as its mean position. And when we displace the bob, when we disturb the bob, what will happen? It will start doing the oscillations, as now we have learned. So it will come to one side first, let us call it this position as A, and then it will go back, and then it will go to that side to B, and it will come back. This is your one oscillation. Okay, and when the bob is doing this one oscillation, will it take some time? Yes, and the time taken to complete one oscillation is known as time period. Is it clear? Time taken to complete one oscillation is known as its time period. And since it is time, period is time taken in one oscillation, that's why we are denoting it by capital T. And what should be the unit of this time period? Of course, second. Okay, after time period we have a term frequency. Okay, now next term is frequency. As we have learned that when we take a simple pendulum and when we disturb the bob, what will happen? There will be oscillations in the simple pendulum. What is an oscillation? When the bob is coming to this side, going back to the mean position, going to the other side and coming back to the position, this to and fro motion is simply known as oscillation. We also have seen time period. Now frequency. See, when the bob is doing to and fro motion, of course it is going to do a number of oscillations. 20, 23, 25, 50, 40, depends. So that means that number of oscillation we are going to count, but in 1 second. So simply frequency is number of oscillations. We are counting the numbers of oscillation, but in 1 second. That will be known as your frequency. Whatever number of oscillations the bob will do will be its frequency. Like in 1 second, if it is doing the number of oscillation 30, so what will be the frequency of the simple pendulum? It will be 30. Is it clear? Now, first thing. Second thing, let's see that what will be the unit of frequency. That we will come, but first we will see what is the relation between time period and frequency. Many of you are already knowing by and frequency we denote by small f. Okay, so frequency and time period are reciprocal of each other. You see, frequency is equals to 1 upon t, or you can say, since they are reciprocal of each other, so whether you can write f is equals to 1 upon t, or you can write t is equals to 1 upon f. Both are correct. Okay. oscillation. Now if you see, if we draw the unit from here, you see that frequency, okay, so now as we have seen that frequency is 1 upon t. Okay, this is the relation of frequency and time period. If I ask you what is the unit of time period, just now we have seen it is second. So now here if I write the unit of frequency, what is the unit of time period? As we have seen, it is second. And what is abbreviation of second? It is simply a small s, and of course it is in denominator, and that's why we are writing it in denominator. Either you write 1 upon s, or what is the power of this s? It is 1. What if we take this s to the numerator? You are aware with the indices. So when we take anything from the denominator to numerator, we always change the signs of the power. So when we are taking it to the numerator, it will become s to the power minus 1, because denominator it was s to the power 1. Now we are taking it to the numerator, it will become s to the power minus 1. So you can say that the unit of frequency, one unit of frequency is s to the power minus 1, or specifically you can call it s inverse. When there is a power minus 1, we call it s inverse. As anything to the power 2, you call it square. Like if I write x to the power 2, you call it x square. If I write x to the power 3, we call it x cube. So likewise, s to the power minus 1, this minus 1 power we call it inverse. Like if I write x to the power minus 1, so you can call it x inverse. Okay, so one unit of frequency is s to the power minus 1 or s inverse, and also we have been reading the unit of frequency as hertz. So you can calculate the unit of frequency in hertz, as well as you can write the unit in second inverse. Is it clear? So this is what the unit of frequency. Now let us come to our next term. We have learned about oscillation, the to and fro motion. We have learned about time period, that is time taken to complete one oscillation. We have learned about frequency, that the number of oscillations in 1 second is known as frequency, and what is the relation between frequency and time period? It is t is equals to 1 upon f is equals to 1 upon t, or t is equals to 1 upon f. Now our next term is amplitude. Okay, now what is amplitude? Let's take the simple pendulum again. Okay, so now what happened if this is the simple pendulum, and of course we displace the simple pendulum? What will happen? It will start doing the oscillations or to and fro motion. It will come to this side. Let's say it is coming to point A and then going back, and then going to the other side B, and then coming back. Okay. Now just imagine in its very first oscillation, if from its mean position it is coming to this side and covering, let's say, a distance of 4 centimeter. Okay, and when it goes to that side, it will do the same. It will cover the same distance, that is 4 centimeter. This is the first oscillation. Can you imagine, or can you tell me that in its second oscillation, the distance covered by the pendulum will be same or it will be less? Of course it is going to be less. Like next time when it is doing the second oscillation, it will cover a less distance. In third time it will cover a less distance. Likewise, because there is air resistance. Now if you have seen anything which is doing a to and fro motion, eventually it will come to rest. Why? Because of the air friction present. So eventually its energy will be decreasing, and that's how after some time it will come to rest. So that means there is a time in which it is covering a maximum distance, because with time the distance covered in one side is reducing. So the maximum distance, one time it will cover a maximum distance, and that maximum distance covered on either side, whether this side or this side, from its mean position is known as amplitude. I think it would be better to understand if I write the definition once, or if I write the term. Amplitude is the maximum distance. It would not be appropriate to call it, we are calling it displacement, since now we know that there is difference between distance and displacement. So the maximum displacement of the bob, are you getting it? The maximum displacement of the bob from its mean position. I hope you all know what is a mean position, where the position of the bob, where it is resting, the very central position. This is known as mean position. Okay, one thing, that when the bob is at its mean position, so it is doing the oscillation, and the maximum displacement of the bob from its mean position, only this side or not only that side, any of the sides. So we can take from either of its sides, from either of the sides. Are you clear with the thing? So that means we are taking a simple pendulum and it will be doing some oscillation and it will cover some distance or displacement. We are considering a maximum displacement covered in either of the side, and that maximum displacement is known as amplitude. And now the amplitude is denoted by small a. Okay. And now you see in the, when we are defining it, when we are writing about amplitude, it is nothing but maximum displacement. Which physical quantity it is? Displacement. So what should be the unit of amplitude? Of course, the standard unit will be meter. So the unit of amplitude would be meter. Is it clear? Now let me see, this simple pendulum is actually very important. That's why I want you all to understand all the topic properly. So far we have learned about the simple pendulum. Is it clear what is a simple pendulum? Which setup is known as simple pendulum? We are taking bob, it is a heavy point mass. Then we are taking a massless and inextensible string, which I have told you, you need to recall. And then we are taking this setup and it is known as simple pendulum. And then there are some terms which we did see already, is that we have seen about oscillation. The to and fro motion is our oscillation. Also we have seen the time period. The time period, can you recall? It is the time taken to complete one oscillation. Okay, I know you are aware of, you know that what is the time period or what is the one oscillation of the bob. I'm not going to repeat it once again, by the way. So here, and second we have seen the frequency. Frequency is number of oscillations in 1 second. And what is the unit of frequency? What was the unit of time period? Second. What is the unit of frequency? Either second inverse or hertz. And what is amplitude? Amplitude is maximum. When we are displacing the bob, it will do oscillation. So the maximum displacement, it will displace again and again from its mean position, but which displacement we are considering? We are taking the maximum one, and that maximum displacement of the bob from its mean position from either of the sides is known as its amplitude, which we denote by the symbol small a, and the unit of amplitude is meter. So these are the terms related to simple pendulum. Okay, and now we are going to see how can we measure time, or what is the idea that I have told you that we are going to measure the time of the simple pendulum. So actually here how are we drawing that conclusion is, we are doing an experiment in which we are calculating, or we are seeing our observation. We are observing something, and on that basis we are going to draw the. One more thing we have not seen is the term effective length. It is very important. Effective length. Okay, now we are seeing the simple pendulum. So here is the string, which we already have seen that string should be massless and inextensible. So the length of the string, what is the effective length of simple pendulum, and why are we calling it effective length? Why are we not talking about only length? Simply if you talk about the length means that is the length of the string. No, we are calling it effective length. Effective length means we are taking the length of the string plus the radius of the bob. Let's say the length of the string is x. You can take it as you want, like 10 centimeter, 40 centimeter, 100 centimeter. So you can take the length, you can measure the length of the string plus we are taking, because of course the bob is in spherical in shape, so there must be some radius of bob, so we are taking the radius of the bob as well. That means actually we are measuring the length from the center of the bob. So from its center to total of the string is actually our effective length. So if I write about what is effective length, it is not only the length of the string but the radius of the bob as well. So it will be x plus r. Is it clear? So this is what known as effective length. Okay, so now let us come to the topic which is our main thing, is that how to calculate the time period of simple pendulum. And for that actually we do some experiment, we perform some experiment, and on that observation we draw a conclusion. What we do in labs, we take simple pendulum and we tabulate the information. Like we take the simple pendulum of different effective lengths. Of course, if we change the length of the string, you can take the length of the string as 40 centimeter, you can take the length of the string as 50 centimeter, you can take it to 100 centimeter. So for different length, when you change the length of the simple pendulum, the time period of the oscillation will be different. Is it clear? You will see, because you will get to perform this experiment in the lab. And when you change the length of the simple pendulum, or more specifically if I say that effective length, because whenever you change the length of the string, there will be total change in effective length. As we know that effective length is length of the string, let's say it is x, and plus the radius. So whenever you change the length of the string, of course the total effective length is going to change. And for every different effective length, the time periods taken by the pendulum will be different. Okay, and that's how what we do for different length, we tabulate the data that okay, for this length the time period, let me write it as, if we take one effective length, the time period is coming different. If we take the second reading, some different effective length, let's say if I write, if we take the effective length as 10 centimeter, and let's say that the time period is coming 20 seconds. If we now change the effective length to 20 centimeter, let's say the now time period is 22 seconds, or not 22, let's say it is 28 seconds. Now let's see the third, if we are taking 25 centimeter, so now the length of the time period of the simple pendulum will be different. Let us say it is 35 seconds. So what are we observing? When we are changing the effective length, the time period of the simple pendulum is changing. Are you getting my point? So this is what experiment we are doing in our lab, or we will do in our lab, is that we will take the different effective lengths of the time period, and we'll see that how the time period is varying. Is it clear? So now if it is clear, I am going to write the conclusion. You see, whenever the length of the simple pendulum is increasing, the time period is also increasing. Are you getting my point? When we increase the length of the simple pendulum, simply you can call it, so there will be increase in the time period as well. So now how are we going to write it mathematically? First thing, that means the time period depends upon length. This is effective length. Okay, it depends and it is directly proportional. It is not yet okay. Time period depends upon length, it is directly proportional. I will tell you what is directly proportional, but not of this power 1. Actually it is root of L, square root of L. Now first we will see one by one this thing. Time period depends upon the effective length as the square root of the effective length. First, what this symbol means, I think many of you are already knowing that this is the symbol of proportional. If time period is proportional to anything, that means when this is increasing, time period will also increase. That's what directly proportional means. Okay, when this will increase, this will also increase. Okay, and there is a term inversely proportional. When if I write something like that, let's say another quantity x is inversely proportional, that means it is in denominator, then we do not call it that x is directly proportional to y. We call it as x is inversely proportional to y, because see, they are inversely proportional, and this means that whenever y increases, as x will decrease, and that's how it is inversely proportional. So we'll see, first we are seeing this, that it is directly proportional. Directly proportional means when this length will increase, time will also increase. But how it is increasing? If you are increasing the length 4 times, the time period is increasing twice. That means when you increase the length 4 times, like if the length was 1 centimeter, now you are making it 4 centimeter. If the length is 4 centimeter, now you are making it 16 centimeter. You are changing it is 4 times. You are changing it 4 times. Then the time period will change twice, two times. So that means it's not that as the length is increasing, the time period will also increase. That length will increase 4 times, so time period will also increase 4 times. No, when the length is increasing 4 times, the time period will increase twice. So that's how we have come to the conclusion that actually it depends on length as a square root of length. See, when you put 4 here, the square root will give you 2. If you put 16 here, the square root will give you 4. If you put 25 here, the square root will give you 5 times. And that's how we have come to a conclusion that time period of a simple pendulum does depends upon its effective length. Please, this length is nothing but the effective length of the simple pendulum, and you all know now what is the effective length of simple pendulum, and it is directly proportional to the square root of length. I hope you all know what is effective length of simple pendulum. It is the length of the string or thread plus the radius of the bob. Is it clear? So just now we have seen how the time period depends upon length. Next we are going to see how the time period will depend upon gravity and all. Achha, by the way, from here we can do one thing. What if you know that if there is a square root written and we take the square root to the other, okay, one thing you know that if the square is written like it is 4, so when you take the square root to the other side, it will become the square root, you know. So when you take the square root to the other side, it will become the square. So if you take the square root to the LHS, it will become t square directly proportional to L. So here, do not get confused whether these two are the same thing, whether you write t is directly proportional to square root of L, or you can bring the square root here, and to this side it will become square. So it is t square directly proportional to L. Now in next class we are going to see the time period of simple pendulum depends on which further factors. Okay, as we have seen, the time period depends on length. On which factors does it depend also, and there are certain factors on which it depends or not, like we have learned about amplitude. So we are going to see whether time period of a simple pendulum depends on amplitude or not. Time period of simple pendulum depends on gravity or not. Time period of simple pendulum depends upon the mass of the bob or not. So we are going to explore these things. Also we are going to draw the mathematical expression. But for today, till here, you please recall everything. You recall what is simple pendulum, you recall what is effective length, you recall what is time period, what is amplitude, what is frequency, and please see their definitions as well, so it will be clear. In next term we are going to see the formula of the time period and how can we solve the numericals using that formula. Okay, so we'll meet in next class.